Welcome to Study Loop.
Hello everyone, today we're doing chapter 17, problem 20. And this problem gives us this compound A, and it says that we have a proton NMR spectrum with peak at 7.6 ppm. And so this indicates that this is an aromatic compound. How are the carbon atoms of the triple bonds hybridized? In what type of orbital are the pi electrons of the triple bonds contained? And how many pi electrons are delocalized around the ring in this compound? So let's first address the first part of this question. What is the hybridization of the carbons in a triple bond? Well, if you see this triple bond is made of these two carbons here. The carbon on the left has one group on the left, one group on the right, so it has two things attached to it. So if we follow the sp3 hybridization, we know that when something's sp3, it has four things, s is to the power 1. Now we have two things in this case, so p needs to be to the power 1 to get 1 plus 1 equals 2 things. So we have sp hybridized orbital. And same goes with the carbon on the left. It's sp hybridized because there's only two things attached to this carbon. So now what type of orbitals are the pi electrons of the triple bond contained in? Well, here we have 4 pi electrons because we have two double bonds. We have 2 pi electrons from this double bond, 2 pi electrons from that double bond. And we know that each triple bond has one set of electrons in a p orbital. So if we draw the p orbital that goes up and down like this, we know that one set of electrons, so these, I'll say the top ones, are involved in this p orbital here. And because they're in the p orbital, they overlap with the adjacent atoms in the ring, the adjacent p orbital in the ring. So they overlap, these two overlap. So they're able to be delocalized around the ring. So they're involved in delocalization and aromaticity. But each of the carbons of the triple bond also has a p orbital in the plane of the ring. So if I were to draw that in blue or in green, we have a p orbital that's perpendicular in the plane of the ring. And now the other set of those electrons, so we use up 2 electrons, we have 2 more. The other 2 electrons are now in these p orbitals that are in the plane of the ring. So because they're in the plane of the ring, they're localized between the carbons of the triple bond. So they're localized in the middle of these carbons in the triple bond and cannot delocalize around the ring, unlike the ones in the red p orbitals. So the green p orbitals are localized in between the carbons, so they cannot delocalize, while these red p orbitals overlap with other p orbitals on adjacent atoms on the ring, so they can delocalize. So in essence, even though we have 4 pi electrons in a triple bond, in essence, only 2 of them are involved in delocalization. So that comes to the very last question of how many electrons are delocalized. Well, we have 2, 4, 6, 8, 10, 12 electrons from pi bonds, from alkene bonds, and then we have 3 triple bonds, and each triple bond only donates 2, not 4 electrons to delocalization around the ring. So we have 12, 13, 14, 15, 16, 17, 18 pi electrons are delocalized in the ring, although we have a total of 24 pi electrons. Only 18 of these are delocalized. Only 18 of these are delocalized because the other 6 are involved in the p orbitals that are between these 2 carbon atoms, so they are not able to delocalize around the ring.